Whenever we build a digital circuit, we need a circuit diagram. Usually, our circuit diagram is derived from a Boolean expression that is customized to our needs. There are many types of Boolean expressions, and this video will explain each one. Boolean expressions in general encompass the entire universe of Boolean algebra. This category includes any logical expression that uses OR, AND, NOT, XOR, XNOR, NAND, or NOR operations. The expression can be as complicated or as simple as needed, using a wide variety of logic gates, or just one. Sum of product, or SOP expressions, are Boolean expressions that consist of product and terms that are summed, ORed together. AB plus B prime C plus D is an SOP expression. ABC plus AB prime C prime plus ABC prime is also an SOP expression. Expressed as a circuit diagram, an SOP expression can be identified by having AND gates feeding into a single OR gate at the output. Product of sums, or POS expressions, are Boolean expressions that consist of sum or terms that are multiplied, ANDed together. A plus B prime times A prime plus B times A prime plus B prime is a POS expression. A plus B plus C times A prime plus B prime plus D is also a POS expression. When depicted as a circuit diagram, a POS expression can be identified by having OR gates feeding into a single AND gate at the output. SOP and POS expressions are very formal in nature. Anything that does not fit this two-level AND or AND format is not SOP or POS. SOP and POS circuits are going to be the fastest implementation of any Boolean expression, as they contain a maximum of 2 levels of logic gates for any signal to travel through. However, they are not necessarily going to be the lowest cost, or even the easiest, circuits to build for all applications. A minimized Boolean expression is a logical expression that uses the fewest possible operations with the fewest possible terms. Many times it is advantageous to derive a minimum expression in order to reduce the footprint of a circuit. A minimum expression will get the job done using the fewest logic gates and the fewest input terms as possible. Minimum SOP expressions are possible to derive. This is an SOP expression that has been reduced using the rules of Boolean algebra to contain as few logic gates with as few inputs as possible. To use an example from earlier in this video, ABC plus AB prime C prime plus ABC prime is sum of products, but is not minimum sum of products. When minimized, the expression becomes AB plus AC prime. That is a minimum sum of products expression. It is also possible to derive a minimum POS expression. This is a POS expression that has been reduced to contain as few logic gates with as few inputs as possible. A plus B prime plus C times A plus B plus C times A prime plus C prime is POS, but not minimum. When minimized, this expression becomes A plus C times A prime plus C prime. There is a small overlap between minimum SOP and minimum POS expressions. Any expression that only uses a single AND or a single OR gate are both minimum SOP and minimum POS. A plus B, for example, is both minimum SOP and minimum POS.